Hello, student. Precalculus, Chapter 1, Section 1, Functions and their graphs. Rectangular coordinates. Cartesian plane, that's the same thing as rectangular coordinate. Cartesian plane and rectangular coordinates, they are the same thing, which they are the XY coordinate. Or XY plane. So they all have the same meaning. If you hear rectangular coordinate or Cartesian plane, or you hear XY coordinate, XY plane, they all mean the same thing. So basically we have an axis. We have an x-axis and y-axis. So you can represent a point by distance along x and from here to here. So if I have a point, let's say any value x1, y1, so this is going to be x1 and the height is y1. Okay. You can look at this drawing here. That's the same thing, x-axis, y-axis. We normally go counterclockwise, saying this is a quadrant 1. This area from here to here is quadrant 1. Then from here to here, a quadrant 2, then quadrant 3, then quadrant 4. And this point here is the origin, 0, 0. So here they say each point is represented by a pair of numbers, a value along x and value along y. Like if we wanted to plot these points, -1, 2, 3, 4, let's try to plot them. So let's assume I have the dividing like that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Then we have the y. So this is y and this is x. So first point is said -1 along x. So I have to go backward because this side is negative infinity. So this is -1, -2, -3, -4, all the way to the largest negative infinity. And here we go, also go to positive infinity. Same thing on y. This is -1 and keep going until negative infinity. Here is positive infinity. So this one, -1, if I go backward, well, there's two ways to plot the point. From the one here, I go -1, I draw vertical line. Then set 2 on y, I go up, this is 2, and I draw horizontal line. This intercept, it is the point -1, 2. So that's the reason they call it rectangular coordinate, because you are constructing a rectangular shape. 3, 4. So 1, 2, 3, I draw a vertical line. If I said 1, 2, 3, and 4, horizontal line, this is my point. 3, 4. 0, 0, we know this is the origin. 3, 0, this on X axis because it has no Y. Okay, 1, 2, 3. Here is the point. 3, 0. -2, -3. There's another way we can plot a point by saying -2, then go down by 3. So you have, this is -3 here. So from the -2, I'm going to go down to here. I stop, that's -2, comma. So if you have a graphic paper, which I prefer when you do your work, to have a grid, all that you need to do just count the squares and you know where is the point. Yeah, here's the answer in the book. Pythagorean theorem and distant formula. What is Pythagorean theorem? We learned that thing in a high school. If I have this triangle, 90 degree, if I say this is A, B, and C, I'm going to say C squared equal A squared plus B squared. This is the Pythagorean theorem. However, name is not important. If I draw this triangle like that, and this is 90 degree, and I call this one K, and this is L, this is M. What is the Pythagorean theorem for this triangle? You have to look at the inclined edge square equal the other 2 square plus. So that the way we don't need to memorize this ABC. We need to understand the principle. The principle is the inclined edge square equal to the other 2 square plus square. So basically, you have to look for that shape to apply the theorem. So how are we going to use this one? Let's try to do it here. If I draw the axis, X and Y, if I pick up any point in the plane of XY and call it X1, comma, Y1, where X1 and Y1 are the numbers, but we should do us any numbers. Get another point, X2, Y2. So basically, if I draw, so this distance from here to here is X1. The vertical distance is Y1. If I go to the next point, the distance to what? The horizontal distance is X2. The vertical distance is Y2. Okay. Let's change the color. What is the distance? Where is this? From here to here. This distance, you can see that x2 take away x1 will give me that distance. Just take subtracting x2 minus x1. That is the distance. How about a vertical distance? From here to here. It is the same thing. Y2 minus y1. Now, if I extend this horizontal line, this distance from here to here is the same as the one on the left because this is a rectangular shape. So basically, this distance y2 minus y1. If I connect those 2 points, I call this distance between them D. Well, what is this angle equal to? It's 90 degrees. Do we see here any right angle triangle? Yes, we see. Here it is. The blue one is the one in the blue is right angle triangle. What can I apply the Pythagorean theorem into it? Right? So we said the inclined edge square equal to the other edges. Well, the other one is x2 minus x1 square. It's like this is a A. So if I call this is a C, and the C square, and this is A square, plus y2 minus y1 square is like the B square. Okay. If I take square root of both sides, D is equal square root of x2 minus x1 square plus y2 minus y1 square. This is called the distance formula. That's our first formula in pre-calculus. This distance formula. All right. And here's the book they use a little bit different. You can see this is the distance x2 minus x1, y2 minus y1. And this is the D, and they use the Pythagorean theorem to find the distance. Here it is. This is the final, the distance formula. Example, find the distance between those 2 points. I'm going to change the color again. You must see the blue color. Okay, to make it easy, you can write down x1, y1 over the numbers, x2, y2 over these numbers, and say here D is equal square root of x2 minus x1 square plus y2 minus y1 square. Let's plug in all the numbers. X2 is a 3 minus x1. Be careful. This negative here in the formula, where this negative come with the number. So I must use a parenthesis for that number, otherwise we're going to have an error. So this is square. So you have two negative, one in the formula and one come with the number. Normally, this is a common mistake. Students, they put one negative and the answer come wrong. So y2 is 4 minus 1 square. So this is square root of 3 plus 2, because negative is positive, square, plus 4 take away 1 is 3 square, equal 5 square is 25, plus 9. That will be square root of 34. If we use a calculator, we can get the answer in decimals. We'll see it in a second. It's pretty easy, just straightforward application. Well, square root of 34 is 5.83. Got the distance. You know, you could verify it by saying 5 square plus 3 square. I mean, that should be equal square root of 34 square. The midpoint formula. We're going to go back to what we did a minute ago. X and Y. We're going to have a point here. X1, Y1, same thing. Same strategy, same method. X2, Y2. Okay, if I connect, so basically this distance again is X1. This distance here, X2, Y1, Y2. If I connect those 2 points, what is the coordinate of the midpoint between those two? So let's eyeball it. If this is the midpoint, M, what's the coordinate? Let's call it XM, YM. Well, that's pretty easy. We don't need to go very heavy duty calculation. Is simple. It is the average of the x's and average of the y's. So XM equal X1 plus X2 over 2. YM equal Y1 plus Y2 over 2. Don't confuse it with the distance. Distance, say X2 minus X1. Here they are adding up divided by 2. Or you can say mid equal, like the way the book has it, X1 plus X2 over 2, comma, Y1 plus Y2 over 2. Page down. So this is the midpoint between 2 points. Example, what is the coordinate of the midpoint? Again, to make it easy on yourself, you can write here x1, y1, x2, y2. Then you write the formula. Best thing, write the formula you are going to use. So med equal x1 plus x2 over 2, y1 plus y2 over 2. Let's plug in. We have x1 is -5 plus 9 over 2. So we're adding, so this negative comes with the number. So you just carries the number. Now, comma, -3 or plus 3 over 2. That will give you -5 plus 9 is 4 over 2. That's 0 over 2. Well, 0 divided by any number is 0. So the answer is 2, 0. This is a coordinate of the middle point. What happens if I have them written this way? If I ask you 9, 3, -5, -3. What is the midpoint? The others, you do the same thing. You can, it doesn't matter. x1, y1, x2, y2. Then med is going to be equal 9 plus, remember, negative come with the 5 over 2, comma, 3 plus -3 over 2. That's going to be 4 over 2, same as before, 0 over 2. Same answer, shouldn't change because they are the same points, 2, 0. The whole idea, be careful with the sign. So this negative came with the number. You have to bring it over. Although there is a plus between them, you can keep it. So you're saying 9 plus -5 is 4. 3 plus -3 is 0. Yeah, if we plot all of those points, we have -5, -3. Here, what they did, that's something you need to learn, guys, that if you have a large numbers, you can scale down. So they're numbering starting 0, and they're using step 3. 3, they are counting by 3. And -3, -6, -9, they are counting by 3. Same thing, 3, 6, 9, -3, etc. Now, first point is -5, -3. If you go back, if this so negative, we're gonna eyeball it. Eyeball it is kind of like here's -5. So we got the point here. For 9, we have 9 and 3. We got this point here. Now, if we connect them, we can see that the intercept with x is 2, 0. That's a middle point. It happened to be the middle point. It is on x. Okay, I'm not going to do the applications. Section 1 is over. Go to section 2. All right. Chapter 1, section 2. We're still working with functions and their graphs. Graph of equation. If I write y equal 3x minus 5, this is the x has no power. So basically we call this one linear equation. Or we call it a line equation. Or we can call it first order equation. So all this means the same things. Here, y is function of x. Y is function of x. This means y is depending on x. So if we give a value for x, we get an answer for y. So based on that, x is independent variable. X is in variable, where y is dependent variable. Okay. And let's draw an example here in the book. Y equal 7 minus 3x. We normally would like to write it down x first, negative 3x plus 7. Then the typical way of writing the equations over line. Later on, we see we can write it. We can write the equation of a line in many different ways, but this one is the most popular one. Plot. Well, how do you plot it? I need to have few points to plot it. And where's the point going to come from? You have to make an assumption. You use any value for x, you find the value of y, and get another one, and get value of y, get another one. Normally, a line need only 2 points to draw. But it's better to have a 3 point for verification, because if they are not in the same line, you know you did a mistake. So let's try to get at least a 3 point. We're going to start with x. You can make a table. Let's do the table here. If this is the value of x, the easiest one to start with is 0 for x. So if x equals 0, y equal negative 3 times 0 plus 7. Well, this is going to go away. Y will be 7. So what is my point? It is 0, 7. So I'm going to get 7 in here. Well, the easiest other number, if I go backward, use negative 1. So y equal 3, negative 3, negative 1 plus 7. That's equal negative negative is become 3 plus 7 is equal 10. Okay, so that means Well, let's write it down here. We have a point called -110. This is 0, 7. So let's take another, we go +1. +1. Then y equal -3 multiplied by +1 plus 7. That's going to give you -3 plus 7. That's equal 4. So we're going to put 4 in here. So that point here is 1, 4. Let's try to plot those 3 points. X and Y. First point is -1, 10. So you're going to go backward by -1. And we have to go up by 10. Let's assume that 10 is here. And this halfway is 5. So you can scale it any way you want it to. Then if I go back up, this is the point here. -1 and 10. Sometimes you don't need to have the same scale in X and Y. They can be different scale. As you see here, my 1 is so large comparing to here. Here's like I'm having 1, 2, 3, and 4, very small. So this way I can make it fit in the screen. So next thing I'm going to say, this is 1, 2, 3, and 4. So what is the next point? We have 0, 7. So this is 6, 7. This point, because where is it? It is on Y. This is called y-intercept. This point here is y-intercept. Because the point exactly on the y-axis. Now, what is the third point? Is 1, 4. This is a 4. And this is a this 1, 4. So let's write down here. This point is 0, 7. And if you look at those 3 points, they look on a straight line to me. We have really good scale. Here you go. We draw down the line by using only 3 points. Well, what happens if I continue? You remember the line is infinite lengths. So if I continue drawing this line, oh, we are intercepted with X. So this one is X-intercept. What is the coordinate? To find, I'm going to set Y. So what is the Y value here? 0. It has no Y. So I'm going to say Y equals 0. Then that's equal to -3x plus 7. Moves this. Here, there is many ways to do things. You can add both sides, 3x. But the way I treated myself by, that's like a scale. I have an equal sign, that means I have left and right. If I move this number to this side, it becomes positive, 3x. Then 7 stay alone. Divide both sides by 3. Then you're going to get x equals 7 over 3. I have some glitches on my pen. 7/3. That's equal 2 point something. I don't know. I think it's 2.2. And if you look at the drawing, I have this is 1 and this is 2. So we are almost correct. So the x-intercept is 2.2 comma 0. This is x-intercept. Okay. What is the rule for y-intercept and x-intercept? To find x-intercept, set y equals 0 and solve and find x value. That's for any graph, okay? For any graph. Let's write it down here. For any equation. We're going to learn a lot more. We're going to have quadratic equation, cubic equation. So that rule will fit for anyone. So right now we are looking at the line equation for any equation. To find y-intercept, set x equals 0 and find y value. Here we have only one, generally speaking. And what we're going to study here, we have always one value for y-intercepts, only one value. X's could be many. So it's always the easiest one to find first is the y-intercept because it's only one value. Here in the books, that's the same problem. We're working on it. They generated about 7 point. We don't need 7 point. I mean, I used only those 3. Myself, that's enough to draw a line. But for extra illustrations, they did more point. So if you draw the line, you can see all in a straight line. All of this must be in the same line. Intercept of a graph, we already talked about it. We have x-intercept, y-intercept. And you can see like here, like an example, this graph is parabola or second order. This one have one y-intercept. However, if I move this down, it's still going to have one y, but have 2x. So it depends. This one is a cubic. This is kind of like x squared, x cubed type. Now, this one have 1 on y, but this is the same one is on x because of the 0, 0 location. Basically, we have 3 on x, 1 on y. However, if I move this graph higher in the space like that, there is no, it have only y-intercept. There is no x-intercept. So it depends on the equation. Don't worry about this one. We don't cover it in this class. It's not exist. And circle for this one has no intersection, but in this location. However, if I move the circle to here, I will have 2 with y. If I move it to here, I have 2 with x. If I move it to here, I will have 2 on y and 2 on x. So it depends where you draw the circle. In this example for a cubic formula, it's asking us to find the x-intercept and y-intercept. I think they're asking for x-intercept only, but let's do find y-intercept and x-intercept. Okay, to find y-intercept, set x equals 0 to find y. So this is the equation. Y equal x cubed minus 4x. Okay, so if I put x0 in here, so we have y equal x cubed, let me write it again, minus 4x, that's equal 0 cubed minus 4 times 0, that's equals 0. So that means 0, 0 is y-intercept. We got that one. How about the x-intercept? Set y equal to 0 to find x values. Okay, let's do that. So 0 equal x cubed minus 4x. When we solve a problem like this, you have to think 2 ways. First, think, do we have common factors? Think. Is there a common factor? Or let's write it this way. Do we have common factors? You factor it out. Can we FOIL out? FOIL out or factor out. If you see here that I can factor the x because it's common between those 2 terms. So if I factor out the x, I'm going to get here x squared minus 4. Okay, based on that, I have 2 solutions. 2 solutions. This equals 0 or this equals 0. So x equals 0, that's the first one that we find out a minute ago, that y equals 0. So the first point is 0, 0. Now take the second part, that x squared minus 4 equals 0. And again, because this is a scale, I take this negative 4 to the other side. Always try to move the negative side to get it positive. It's become positive 4. So x squared equals 4. Take square root of both sides. x squared equals 4. We're going to get x equal, remember, because this is variable, we have two answers, positive and negative 2, because square of negative 2 is also 4. So we have two answers. So that means we have negative 2 comma 0, positive 2 comma 0. How many points do we have? 3 points of intercept. 3 points. See, we call these x values, but this is are the point. You have to distinguish the difference between the values for the x and y and the point itself. The point have x and y. So this is x value. And these are the point. 3 points intercept with x. Well, this function is a cubic. It have an x cube. Okay, let's give you some review here. Typically, in general, if you have x cube, the shape will look like an S sideways. This is the x cube. If it parabola, if this is x squared, it's going to look like a U shape. Okay. Well, there is some more. If this is down like this is negative x squared. If I draw this in the opposite way, this is negative x cubed. So because this is positive, so our shape should look like this. So at least I know how it look like. It look like that. Let's try to plot it. We have, I'm going to skip it, negative 2 comma 0. That's the first x-intercept. We have 2 comma 0. And we have those y on x and y intercept 0 comma 0. Now, how I draw this, you can see this plot of I need to always start from the left. So seeing this is a lower point, if I kind of like, pick up reasonable, you will learn how to do that. So I'm going to pick up this point to start from. I'm going to go up until I go through this point. Now, remember what after that, I have a curve down. So I have to curve down. And when I go down, I must go through the intercept point. And again, there is a curve up. So I need to curve up and go through the point. Here we go. We plot it. But just using the x and y intercept and the knowledge, how is the shape look like? Okay, they are showing us a drawing in the book. Same thing we did, but in different scale. Symmetry. Symmetry, when we have a shape either symmetric about x or symmetric about y. So if I have, like here they are showing on the book, if I have this shape, and this is the x-axis. X-axis, you can imagine this is like a mirror. When you have a mirror, what is the reflection? This is the reflection. So this is called symmetry. This is reflection. We're going to call it reflection. So the reflections about x is the symmetry about x-axis. Now, if I have this shape halfway, like that, and this is the y-axis, and this is the mirror side. And what is the reflection? If you flip it over, that is the reflection. Okay, that's called symmetry about Y, reflection. Symmetry about Y. Also, we have a symmetry about the origin. When you take symmetry about the origin, you have a point here. So when you say symmetry about the origin, so this point have an x, y, then if you go to the other side, the r coordinate is negative, negative. So that's what we call a symmetry about the origin. When we have symmetry about the y-axis, the x is negative, and here's the x is positive, whereas the y is both of them positive. They are having example here, y equal x squared minus 2. If you plot it, you see this symmetric about, exactly symmetric about y. Circles. Okay. We need to develop the equation of a circle. Let's make an assumption. Let's say I have a circle in XY plane. X and Y. Well, this is called as the center. C is center of the circle. It has a coordinate H and K, any number. So C coordinate H comma K. If I pick up any point on the circle, any point, and the coordinate, when we say any, that means I'm going to use X and Y. There's no specific. If it's specific, I would say X1, Y1. Because this is not specific, it could be here, could be here, could be anywhere on the circle. Okay, and I choose that location, so randomly. It's any location on the circle, then I use X, Y. Well, those 2 points, what is the distance from here to here? We're going to call it R. This is the radius. R is the radius. Okay. Well, we already learned how to find the distance between 2 points. What is the distance between those 2 points? D, which is R here, D is equal R equals square root of, if this is the second point, this is X2 and this is Y2. And this is X1 and this is Y1. So X2 minus X1. So basically that X minus H square plus Y minus K square. Well, basically this is the X2. This is X1. This is Y2. This is Y1. Now square both sides. Square both sides. We're going to get R square equal X minus H square plus Y minus K square. This one called equation of a circle. Equation of circle. Remember, R, H, K are numbers. Could be given or could be need to be found. are numbers. X and Y are variable. That could be anything, or variable. Okay. So the equation must have this shape. This is always X and this is always Y. And the other one are numbers. Example. What they're giving us, the center of the circle C, -1 and 2. That's the center coordinate. Well, this is automatically H and K, right? Automatically. And they give us 1 point in the circle. This is a point. This is not X and Y. This is 1 point. They said find the equation of that circle. Well, we need to find first, find R, H, K. Well, we already found the H and K. So H is equal -1, K is equal 2. How about the R? The R is the standard distance between those 2 points. R is equal square root. If you call this is x2, y2, this is x1, y1, then we're going to say x2 minus 1 square plus 4 minus 2 square equal square root of negative, positive. This is 4 square plus 4 minus 2 is 2 square. That's going to give us square root of 16 plus 4. That's square root of 20. So that is the R value. Then in the equation of the circle, I'm looking for R square equal 20. So what's the equation? Remember, equation is R square is equal X minus H square plus Y minus K square. Well, let's plug in. How much is R square? R square is 20 equal. X will not change, will stay X. Minus 1. Okay. Square plus Y minus 2 square 20 equal X plus 1 square plus Y minus 2 square. That's the answer. That's the equation of the circle. It must be X, you must have X and Y in the equation. Okay, we'll stop over here because that's the end of section 2.